You write an Android app. It ships. 6 months later, the business asks for an iOS version. You look at your code base, the network layer, the data models, the caching logic, the business rules, and you realize none of it can move. You start over. The same bugs you fixed in month 2, you fix again in month 8. The same architecture decisions you agonized over, you agonize over again. This is the hidden cost of platform-siloed mobile development, and it has eaten years of engineering time across the industry. Kotlin Multiplatform is the answer that does not ask you to abandon Kotlin, relearn a framework, or bet on a renderer you don't control. This episode introduces what KMP actually is, not what the marketing says, but what the compiler does, and shows you the full app we are going to dissect together throughout this course. Before defining what Kotlin Multiplatform is, let us clear up 3 things it is not. It is not a new language. You write Kotlin, the same Kotlin you use for Android, and the Kotlin compiler targets multiple platforms from the same source. It is not a UI framework. KMP is a build system and compiler capability. You can share UI if you add Compose Multiplatform on top, but that is a separate opt-in decision. And it is not React Native or Flutter. React Native bridges to native widgets through a JavaScript runtime. Flutter ships its own Dart runtime and its own Skia renderer. Your iOS app does not use UIKit at all. KMP emits real platform artifacts, JVM bytecode for Android, a native Objective-C compatible framework for iOS. The platform code that runs on device is real native code, not a wrapper around a wrapper. Here is the mental model that makes KMP click. Imagine a triangle. At the top is your shared Kotlin source, business logic, data models, network calls, Compose UI if you choose. At the 3 corners of the base are the compilation targets. Android gets JVM bytecode, the same bytecode any Android library produces. iOS gets an Objective-C framework built with the Kotlin native compiler. Swift can import it directly. Desktop JVM and WebAssembly sit alongside those. The key insight is that each corner is compiled independently and completely. The Kotlin native compiler does not interpret Kotlin at runtime on iOS. It compiles to machine code, garbage collected by the Kotlin native runtime on iOS. It compiles to machine code. This is why you can drop from shared Kotlin to platform-specific code at any layer boundary, and the result on each platform is indistinguishable from code written natively in that platform's own toolchain. Sharing business logic across platforms has been possible with KMP for several years. What changed in 2020-2024 is that Compose Multiplatform reached stability for iOS. That means the UI layer can now be shared too. Compose Multiplatform uses Skia as its renderer on iOS and desktop, the same Skia that powers Flutter. But unlike Flutter, the language is Kotlin, the toolchain is Gradle, and you can drop into UIKit interop at any component boundary you choose. In this project, MyEuroStatApp, the Compose UI for all 8 feature screens lives in common main, shared between Android and iOS. The population pyramid you will see later in this course is drawn pixel by pixel using Compose Canvas, and that canvas runs identically on Android via the Compose for Android renderer and on iOS via the Skia layer that Compose Multiplatform provides. Let us see what we are building. MyEuroStatApp pulls live statistical data from the Eurostat public API, the European Union's official statistics bureau, and visualizes it across 8 subject areas: population, economy, environment, trade, transport, tourism, social indicators, and science and research. The app ships on Android and iOS from the same codebase. When you tap the Population tab, you see a demographic pyramid with male and female bars for each age cohort across 27 EU countries. The Economy tab shows GDP, inflation, and government deficit. Environment shows greenhouse gas emissions by sector. Each of these pulls a real JSON from ec.europa.eu on every launch, caches it locally with SQLite, and serves stale data with a banner when you are offline. This is not a toy app. The architecture patterns you learn from it are the same ones you will use in production. The project is organized as a Gradle multi-module build. Open settings.gradle.ktes and you see 16 module declarations. Group them into 6 layers. First, the app shell, Compose App, which is the Android application, iOS framework host, and desktop entry point. Second, the foundation layer, core, command, holds, the result type, app arrow, and dispatcher provider. Core JSON-stat holds the JSON-stat 2.0 parcel. Third, infrastructure, core network, wraps a shared Ktor HTTP client. Core database, wraps SQLite. Fourth, navigation, core navigation holds the decompose root component. Fifth, the design layer, core V is the design system with tokens and 20 components. Core charts is the canvas chart library. Sixth, the feature layer, 9 self-contained feature modules, 1 per subject area. This structure is not decoration. Each layer boundary is enforced by Gradle. A feature module that accidentally imports from another feature module will not compile. 3 reasons for the multi-module structure, and all 3 matter in production. First, compile time layering enforcement. The walls between modules are not architecture conventions you trust developers to follow. They are build failures. If a developer in feature population accidentally imports something from feature economy, Gradle refuses to compile it because there is no declared dependency. Conventions get violated under deadline pressure. Build failures do not. Second, build parallelism. The 9 feature modules have no dependencies on each other, which means Gradle can compile all 9 in parallel on a multi-core machine. On a laptop with 8 cores, that is a meaningful reduction in cold build time. Third, onboarding clarity. A new contributor can open feature population, read its 4 subdirectories, data, domain, UI, DI, and understand the complete pattern. Then they can apply that exact same pattern to any of the other 8 feature modules without asking anyone. Open feature population and you see a canonical clean architecture layout. The data directory holds the API service, the cache DAO, and the repository implementation. The domain directory holds the repository interface, the use case, and the domain data models. The UI directory holds the decompose component, the UI state field type, the intent field type, and the compose screen. The die directory holds the coin module that wires everything together. This 4-layer pattern repeats identically across all 9 feature modules. When you understand feature population end-to-end, you understand 75% of any other feature module. The only thing that changes is the dataset code in the API service, the shape of the domain model, and the chart type in the screen. The plumbing, result wrapping, stay while revalidate caching, decompose component lifecycle, coin injection is identical in every feature. Let us be concrete about versions. Kotlin 2.1 provides the compiler. Compose Multiplatform 1.7 provides the shared UI runtime. Decompose 3 handles navigation. We will spend a full episode on why Decompose instead of the standard Android X navigation, which is Android only. Kotor 3 is the HTTP client. The key point about core is that you write one client configuration in common main, and expect actual provides the engine or HTTP on Android, Darwin URL session on iOS. SQL Delight 2 is the database. Same SQL schema file compiled to type-safe Kotlin on all platforms with a native driver per target. Coin4 is the dependency injection container, no reflection, no annotation processing, works on all KMP targets including iOS native. Coroutines 1.9 and Turbine for flow testing. Every library in this stack was chosen because it has real multi-platform support, not a thin Android wrapper with a stub on iOS. A brief note on the data source, because it shapes some architecture decisions. Eurostat serves statistical data in JSON-stat 2.0 format. This is a compact format for multidimensional data cubes. A response for population data with dimensions geographic area, year and sex, at 27 countries, 24 years, and 3 sex categories, packs all 1944 data points into a single value array with a separate dimension dictionary that decodes each position. Parsing this is not trivial, which is why core JSON-stat exists as its own module with its own tests. The API is free, requires no authentication, and covers dozens of economic and social indicators. The base URL for every request is the Eurostat Dissemination API, and each dataset has a unique code, demo double GPA for population, mama ASCAR double GB for GDP, and so on. All the codes used in this project are documented in CLAUDEDMD. This course is structured as 12 episodes, each focused on one horizontal layer or cross-cutting concern of the codebase. Episode 2 covers Gradle setup, the version catalog, convention plugins, and expect actual. Episode 3 covers the core contracts, result, app error, dispatcher previter, and safe fetch. Episodes 4 and 5 go deep on networking and JSON-stat parsing. Episode 6 is SQL Delight. Episode 7 is the repository pattern with stale while revalidate and turbine testing. Episode 8 is Decompose navigation. Episode 9 is Compose Multiplatform and the design token system. Episode 10 is Compose Multiplatform and the design token system. Episode 11 is Coin dependency injection. Episode 12 covers testing, packaging, and release for both Android and iOS. Every episode references specific files and line numbers in the real codebase. This is not a contrived example built for the course. Every line you see on screen exists in the production repository. Kotlin Multiplatform lets you share the parts of your code base that are expensive to duplicate: data models, business logic, network calls, caching, while keeping platform-specific code exactly where it belongs. This project, MyEuroStatApp, is a complete end-to-end example. Real API, real cache, real charts, shipping on Android and iOS. The repository link is in the description. Clone it, run the Android build with /Gradle, Compose app install debug, and you will have a working app on device in minutes. The next episode dives into the Gradle setup, convention plugins, version catalog, and expect actual, which is the mechanical foundation everything else in this course rests on. Subscribe for more on Android AI tooling and Kotlin Multiplatform.